Hello everyone. In this session, you're going to see two more examples for push down automata. So both are about a power n, b power n, but the difference is this n and m are different. Like first problem that I'm going to take is n value is greater than m. So n value greater than m in the sense like you will be having some extra a's with less number of b's, and both n and m are greater than or equal to 1. At least one a, one b should be there. And next problem, you're going to take it in the reverse of it. Okay, the number of B's will be more than the number of A's. So for both the categories, we are going to check how does your push down automata works. Okay, so here as per the procedure, the number of A's are more than the number of B's. So how does the push down automata can be constructed? For all the A's, we can push into the stack, and whenever a B comes, we are going to cancel one A for it. So at the end of input, if stack consists of at least one A, the input can be accepted. So that is the procedure. So you'll be having a stack, and the transition actually starts from the starting state. So from the state Q0, first step is to push the Z0 into stack. What is the condition for it? Without any input, if the stack is empty, push this Z0 into stack. So first step, Z0 will be pushed into stack. And next step is we have to scan the input from left to right. So first element surely will be A. The reason is m comma n is greater than or equal to 1. At least one A should be there. So when A is there and the topmost element of stack consists of Z0, we are going to push A Z0 into stack. So first scan the input A, put it into stack. And second step, this A will be popped out, and one input, the next input will be A. Okay, so we'll be having n number of A's, right? For all the A's, we are going to push that into stack. That is the procedure. So for each step, one element from the topmost element of stack will be popped out and one input will be taken, and we are going to do the process. Okay, so we'll be pushing this A into stack. So for all the A's in your input, everything will be scanned and it will be pushed into stack. Okay, so till this, we are going to have the transition in Q0. Q0 is a place for pushing all the element into stack. And next comes your popping operation. So when your input consists of B, okay, when the input consists of B, what happened each step of transition? One A will be popped out. This A will be popped out and one B will be taken for input. So what we are going to do for this B, this A will be cancelled. So the element that is popped out of stack will not be pushed back. So we are not going to do anything other than this. The element will be popped out automatically and that's it. Okay, nothing will be pushed back into stack. So for all the remaining B's, we are going to do the process. For all the remaining B's, we are going to pop one A out of stack. So next step, this A will be popped out and this B will be there. For this B, this A will be cancelled. Okay, so for this condition, the number of A should be greater than M. So when the number of A is greater than M, the stack should consist of at least one A as a pending. Okay, so you can create a final state here, Q2. Okay. At the end of input, if all the inputs are processed, if there is still an A in the stack, then we can accept it. We can make the transition to final state and we can accept the input. Okay, so this is acceptance by moving to final state condition. Okay, let us take one example and use instantaneous description for show the working of it. So here, when you consider the input symbol as starting from the state Q0, ID description, starting from this Q0, when my input is 2A, 1B, and without any input. So first step, we are going to push the Z0 into stack. Okay, so next step is Q0, A, Z0. You're going to push this A into stack. A, Z0 will be there. And Q0, A, comma A, you're going to push this A into stack. A, Z0. Okay, so till then we will be in Q0 state itself. Now Q0, when the input is B and A, when the input is B and stack consists of A, we are going to make the transition to Q1 state. And what we do for this B, this A will be cancelled. So all the inputs are cancelled and you will have A Z0 into stack. Okay, so next step is at the end of input, if there is A alone in the stack, we are making a transition to Q2 state with A is Z naught. Okay, so at the end of input, transition is in final state, the input is accepted. Clear? So this is acceptance by moving to final state. If you want to do the same with acceptance by empty stack condition, we have to empty the stack. Okay, so one transition can be given as from Q1 B comma A epsilon. We can make this Q2 as a non-final state, and without any input, if A is in stack, the input need to be accepted. So we're going to pop out all the elements in the stack. So what all the possible elements that can be there in the stack? Without any input, if A is in the stack, you're going to pop it out. Without any input, if Z naught is in the stack, you're going to pop it out. Okay, so what happened with the remaining process here? I'll do it here. So this is acceptance by moving to final state. In other case, after this step, what can be done now? If you want to follow this procedure, okay, from Q1, when the input is epsilon, so this can be made, we are going to have this transition, right? Q1, when the input is epsilon and stack consists of A, we are making a transition to Q2 state with removing this A from stack. Okay, this A will be popped out of stack. And next step is, will remain in Q2 state itself. When the input is epsilon, when you have Z naught in the stack, that is also popped out. Okay, now at the end of your input, if your stack is empty, so the input is accepted. Okay, so this is two-way acceptance. When you can design a push down automata in moving to final state, we can convert that into an empty stack condition, and the reverse also is possible. Okay, so this is a push down automata for the language of A power n, B power n. Number of A's are greater than or equal to, sorry, number of A's greater than, strictly greater than number of B's. Okay, so the same when you want to do it with the reverse of it. Okay, so let us do it for number of B's greater than. So that is a bit complicated than this. Okay, so you have to understand the logic better. So when you want to proceed with A power n, B power m, and n comma m greater than or equal to 1 and m greater than n. Okay, so that means the number of B's are more. Okay, so the number of B's are more than the number of A's. So the procedure is going to be the same. So Q0, Q1 transition is going to have the same set of possibilities. So in Q0, you're going to put all the elements into stack starting from epsilon, first push the Z0 and A comma Z0, push A Z0 into stack. For all the A's, we are going to put it into stack. Okay, so whenever a B comes, you are going to start your cancellation process Q1. Okay, when your input consists of B and stack consists of A, you're going to pop it out and you're going to put it into a self loop for all the B's. You're going to pop out one A out of stack. Okay, so next remaining part shows how you're going to proceed with it. Okay, now Z0 is there in the bottom element of stack and you're going to scan one input. So for all the A's, you're going to put it into stack. Now, when you complete this process, what happened? Next step is when your input consists of B, one element from this A will be popped out. Okay, so for this B, this A will be cancelled. And next step, this A will be popped out, and for this B, this A will be cancelled. And if your number of B's are greater, you will have a transition like in your input, you'll have a B, and in your stack, you'll have Z0. Okay, so that is your acceptance criteria. In Q2, you can make it as Q2 as a final state. When your input consists of B and stack consists of Z0, you're going to have this transition. You're going to make a transition to final state. Okay, and one more thing you have to concentrate here is, I'll just show it with an example. Okay, with an instantaneous description, I'll show how it is actually working. So I think till this it is clear, right? Till this step it is clear. Now, I'll take one example. Starting from Q0, if my input consists of A, B, 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 okay, with epsilon. So first step, I'm going to put this Z naught into stack. And next step, for all the A's, I'm going to push 1A, remove 1A from stack, input, put it into stack. And next step, Q naught, I'm going to take the next A, I think 4 B's, right? And put it into stack. Okay, so when you have B and A in Q naught, when you have B in the input and stack consists of A, we are having a transition change from state Q naught to Q1. So for this B, this A will be cancelled. So we'll be having 3 remaining B's and A is Z naught. Okay, and next step in Q1, for all the B's, we are going to cancel 1A. So we'll remain in Q1 itself. The input will be BB and the stack consists of Z naught. Okay, now this is the acceptance criteria, right? The number of A's are lesser than the number of B's. It means the number of B's are more. So in this case, what you're going to do, we are going to have a transition. So when the input consists of B, you're going to make a transition to Q2 state. Q2 is the final state. So for this B, 1B will be consumed and Z0 will remain in the stack. So we cannot stop it at this place. You should know the reason. See, input acceptance is defined only at the end of input. Now you have one extra element B in the stack. Okay, so you may be having n number of B's. The number of B's are more, right? So you may be having n number of B's in the stack, sorry, in the input. So for each input, you're going to pop out the Z0 each time and push it back. Pop out, push it back. Okay, so it is like consuming process. So the next step here can be defined as in Q2, we'll pop out this B and Z0 will be there in the stack. Okay, now the input is accepted. At the end of input, you have to define the process. That is very important. Okay, this is acceptance by moving to final state. Q2 is the final state. So acceptance by moving to final state. Another thing, when you want to accept it by empty stack condition, you can have the transition as epsilon. Okay, you can have one more transition here added as when B is there in the sorry, when all the inputs are processed, Z stack consists of Z naught alone, pop that Z naught out of stack. Okay, so this will become acceptance by empty stack condition. You can, for this pink highlighted thing, you can make this Q2 as a non-final state too. Okay, so this is how we have to proceed on pushdown automata here. Like whenever it is a pushdown automata, we have stack as an additional unit. So when you have an additional memory unit, it is better we can push any element, pop any element out of stack easily. Okay, thank you.